Hi, my name is Bruno Gobato. I'm speaking directly from Brazil, and in this video we are going to show you how to create your own machine learning robot to help give X-ray diagnostics based on image vision, image classification, AI, artificial intelligence. We're going to use the Google Cloud platform that is open for everyone, and we're going to show how can we done. So let's move on this webcam over here. So for this video, we're going to use Google Cloud platform. Once you log in your Google Cloud platform, you have to have a developer license. It's very easy to create using your own Google login. And in Google Cloud platform, we have lots of services. And the services that we are going to use is the vision service. That's right down here. Here we can see vision. This is for computer vision service. So we're going to select vision. And here we have our dashboard. Here we can create our models to train and test our models. Our models are all the data set that we want the computer to train and to help us give the diagnostics. So here I have my models that I have already tested. It's in Portuguese, but my first model is this one, X-ray, that I teach my computer to give information about the incidence for shoulder X-ray, if it's AP view, lateral view, or axillary view. And then we enhanced our model to give more diagnostics. Is that what we're going to show here? So in this model that we have tested, we have more than 3,000 images. It's not so much. It's the image that we have from our own clinic. And here are the images that we have uploaded to the platform. And we are going to teach Google how to give diagnostics based on this image. So first of all, we are going to import our image. We're going to import X-rays or any image that we want to give Google to predict what that image is. So once we have imported our image, we are going to give labels to that image. So I'm going to click here on this first image. This is a shoulder view. So here are my labels. I have decided to give these labels, and it's based on these labels that Google will predict what this image is. So in this case, this is a shoulder AP view. It's a shoulder AP normal shoulder and shoulder normal. Okay, so I gave for this image 3 labels, and we are going to do it image by image. Of course, we can do in a multi-image view. If you upload a set of images from the same label, you just click all the images and give the same label. So I'm going to move forward. I'm going to show here another example. This is a hip image that I have already given the diagnostics for Google. So this is a hip AP view, and this is a hip AP view with arthritis. Then, once we have a good amount of image, we're going to train this model. What is to train? Google will upload this image to its cloud platform. It will use image vision computer algorithms to help understand different patterns in the image and try to predict what we are going to have. And so we're going to show, we have already done that, and we're going to show you how we can test and see if our images are okay. I have downloaded from the internet some images. These are, of course, not the same image that we have trained Google, so it could be easy. So we have here some knee, some shoulder, and some hip images, and we're going to test if our vision computer can give the diagnostic based on that image. So I'm going to upload a series of images that I have just downloaded from the internet. They are hip, knee, and shoulder views. Let's move over here. I'm going to open, and these images are going to be uploaded to Google platform. Google will predict what we have. So here are the results that we have just uploaded. This is Google predicted that with 100% sure this is a hip AP view, and 72% sure that it's a hip AP normal hip. The another view, this is a hip AP. This is a 60% sure that this is a hip arthritis, and 53% sure that this is a hip normal. And one thing that's very interesting is that these images are different. This image is a cropped image. This image is a home image of the view, and Google does not understand exactly what we are looking for. He does not know that we are looking exclusively to the joint, but he can, with a great amount of image, try to understand the difference in this image to give this diagnostics. Let's move on. This is another view. All you can see that they are very different images from each other, and this Google predicted it's 100% it's a hip AP view, okay, and with 56% sure it's a hip arthritis. Very good. Now let's see the knee. This is 99% sure it's a knee joint, okay, and 96% it was pretty sure that this is a arthritic knee, and he was correct. Here is 100% it's a knee, and 100% sure that it's a knee arthroplasty. I told Google to look for this image, and he knows that is a knee arthroplasty. In this case, he has 100% sure it's a knee, 99% it's a knee AP view, and 100% sure that's a knee AP normal image, and he was correct. Again, here we have 100% sure it's a shoulder AP view. We have 100% sure that's a shoulder 63% it's a shoulder normal view, and 70% shoulder normal. And this is how we can enhance Google. So by the time we import more images, we create to train, and Google will have more information about that image, and he can predict our model and can predict the image that we have done. We can do this with any kind of image. We can do this with MRI, we can do this with CT, but remembering that Google is not looking for a specific part of the image. He's looking at all the part of the image, and if you are interested in looking only in the specific part, we have to hope that Google or the algorithm look for that specific part of the image and find that this is different or the same as the data set that they have. So this is a very small video. I'm showing you how to create and test your own robot, your own machine learning robot, and test and create your own data sets. Thank you very much. Bye-bye.